This is the EcoGolfer. It's designed to pick up golf balls around a golf course no matter what terrain it's on. What you're seeing here is its tele-up mode, where the driver can control the robot by a controller. Here's a quick demonstration of the code generator for the robot. So it will take the parameters that you give it, put it into the template code, and then give you the final result, which you can plug directly into the robot. So we're going to start up the program. It prompts you with what you would like the length to be. We'll say 6.5 feet. And what the width of the patrol zone will be, we'll say 5 feet. And now this will spit out your output code. As you can see, we will only be repeating the loop 4 times because of the width we were given. And our forward target position is at 2,600 based on the length that it was given. And this Java code can be copied directly into Android Studio and sent to the robot, as Java does not care about indentation. You can just copy it and paste it on over, and it should work just fine. There should be some video giving a demonstration of what those look like as well. Unfortunately, after our intake was finished and we went to test out the Patrol Autonomous, it became kind of unsafe to do so due to the ground being very wet and our electrical components being pretty sensitive. So I'm going to show you a brief outline of what that Patrol Autonomous looked like, and you can compare that against the example code from the generator. So essentially the robot has a point it starts at, which is just where it's placed when the program starts. Then, based on user input, it will go a certain length for the dimensions given. Then it will turn 90 degrees based on the IMU gyro sensor that is built into the control hub. And we do this because turning in grass can often be unreliable when you're just relying on rotations without an odometry wheel. So we are using the gyro sensor so that way we always know we're turning in the correct direction. We move forward the same length of the robot, so that way after we hit this path, then we hit the path directly next to it, and so on. So then it repeats itself, and beforehand it calculates exactly how many times it will have to repeat itself based on its width and how many times it has to repeat until it gets to the end location. So one loop would look something like, just like this first part, where you go forward, and you turn again. And then you repeat that. And so on and so forth until you get to the very end. And then the program stops, and you can collect whatever it picked up in that time. If you have any questions about this or the code behind it, make sure to ask us during our live pitch session. We apologize for this inconvenience. We wanted to show it off to you as well. Unfortunately, that's sort of out of our control, but hopefully before the live pitch we have a chance to try it again. If not, I hope this gave you a good idea of what that would look like, and hopefully you can compare that against the example code and kind of work out exactly how that would work for this project. Here's a very brief summary of the robot itself. So it is a 4-motor drivetrain connected to these tires, which are foam, conform to the terrain around it. Since it's not on flat ground, that's very important. Then we have our control hub, expansion hub, and battery. This just keeps the robot powered and sends out all commands to the motors and other modules on the robot. We have our intake, which is composed of 2 core hex motors, which are on the same axle with these grippy wheels. These are constantly spinning forward, which sucks golf balls up just underneath. It is gravity fed, so that way, no matter what terrain we're on, it can still pick up the golf balls just against the ground like that. We have netting on the inside to keep the golf balls in place after it puts them in, if the flywheels don't keep it that way already. And also these one-way ramps, which also help keep the balls in place after they have been collected. And then finally, we just have our polycarbonate shroud, which keeps all of our electronics safe from any kind of dirt or debris while it's traveling around the golf course. I also forgot to mention, The control hub is what hosts all of our code and also communicates with our driver hub. So this way, any code gets sent from the control hub to the driver hub, so we can start an autonomous program from anywhere or control teleop from anywhere where we're within the Wi-Fi range.